All right, so for this problem over here, we're told that radium-223 has a half-life of 3.6 days. So this right here is T1 half. Okay. They tell you that a sample of 8.51 grams was initially used. So I know that this is going to be N0. Okay. And it says when the sample was measured again, only 2 grams were found. So this is going to be NT. This is what you have after time has passed. And when it says how old is a sample, you're always going to be looking for time here. Okay, so first thing you want to do for this equation is take a look at what we have. We have our half-life, you know N0, you know NT, you're solving for time. When you're solving for the time, you could actually use either equation, the first one or the second one. And if I'm given an option, I actually like to use the second one just because it's a little bit less work on the calculator, but really either or would work. So it's natural log, okay? And we're going to take the smaller number over the bigger number whenever you do this. So it's 2.0 grams divided by 8.51 grams is equal to negative k times time. Okay. Remember, for this problem, we're actually going to be looking for time. So in order to do this problem, we do need to plug in what the k or the constant is going to be. So the constant is just a really simple equation. It's 0.693 divided by half-life. And it's 0.693. And our half-life here is 3.6 days. Okay, so if you punch that on your calculator, you end up with 0.1925. Okay, so this is going to go right in there for the k, and then we have natural log, and I'm going to go ahead and simplify that. It's 2 divided by 8.51, and when I punch that out on my calculator, I get negative 1.44809 is equal to negative k times t, and we solve for the k, it's 0.1925, and we have time. So pretty much the rest of this is just solving for t. We're going to divide both sides by the 0.1925. And that cancels. And we're going to get 7.52257. I'm going to just round it to 2 places after the decimal. Okay, and for the units, you know that you're looking for how old is a sample, and we could figure this out by looking at the half-life. So we have days, so you know that we're looking at 7.52 days for this answer, and that's all.